Hey everybody, welcome back. This is additive manufacturing, and since I am not going to be available today, Wednesday, I jumped up into my office to make a quick lecture for you. Sorry about that. I need to go across town and be with my mom, who's in the hospital. So this is going to probably go on for a bit. So we'll just have to adjust as I have to adjust. But for additive, a couple things I want to go through. I'm going to make this a little smaller. Week 4, that's where we're at. What I'm going to have you do, there's a quiz coming up. So if you haven't seen that, I made it available until the 28th. So that's through the weekend. So um, if you have any problems with the mass properties, let me know. I can probably help you. But get that done and get that loaded by the 28th. And then the other thing I'm going to have you do is work through the simulation software in SolidWorks. So I wanted to show you where that was. So if you haven't been in here, there's a help question mark right here in the upper right corner, and tutorials are right there. So when I do that, move me out of the way here. Actually, yeah, whatever. Kind of can slide it all the way off, can't I? All right, so it's right here, all SolidWorks tutorials. Okay, and then the one I want you to work through is called Simulation Express. And what Simulation Express does, I wish, here, I'll pull up one of the examples. It allows us to create a part and then also load the part, fix the part, meaning that certain parts of it have to be fixed. They can't move around. Put a load on it, put a material to it. So you have to put a material to it in order for it to do the finite element analysis. And then it'll give you a stress curve and stress locations. So you can see down here, we have very low stress levels. And then as we go up, we have much higher stress levels. So the red is higher. So it does this analysis. You can see that it's finding some stress next to holes, stress concentrations, and then other areas where it loads up. So we're going to do this actually with a chair, but for this tutorial, it has you make, actually, it has you open a file. So if that file is there and you can open it, then great. But if it's not there, then you're going to have to make your own part, which is what I said in here. Says, if the part will not open, generate a part for you to practice on. And this can be a simple part. You'll see with, they use a hook. But so you can generate a part and then go through the steps of running these simulations. So this is the first step that we want to do before we head into optimization. So I'm going to get through this and we should be able to run some simulations. And I'm thinking I'm going to have you run some simulations for the strength and materials class too. So that should be super fun. All right, it says no lecture this week, and that's just because I can't be in class today. So that's what that means. All right, I think that's pretty much it. The quiz and then the Simulation Express for additive. Oh, one other thing. I'm going to spin the camera around and show you your assemblies. So I'm getting the printer to, function. It's working fairly reliably now, so that's good. Maybe I'll zoom you into these. But I did have to print them double scale. So these are twice as big as we made them, okay? But they come out just like this. They did put support, in these littler, in these clearance areas. So I had to add the support. Oops, where do you all go here? What is happening? Oh, I'm gonna stop the share. Okay. And I'll reopen the share. Okay, perfect. All right, so it did add support in all these clearance areas. Since these are double scale, that's a 20 thousandths in there, but you can see that it broke free. Like I was able to just force it and break it free. And the smaller sections, we couldn't do that. So that worked well. This one was interesting because it was really frozen and I literally grabbed it with pliers and grabbed it here and then broke it free. So it does spin and it's got a little rough spot in there, but the more you work it, you can hear it maybe grinding. It's going to grind that break material out, but there's no exits for it. So if we motion, we have to think about, okay, there's going to be breakout material in there. How am I going to let it exit? If I grind it up, it'd be nice to be able to get it out of there. This one worked too. It's not super smooth either, but I think the more you work it, the more it would loosen up. But 20,000 seems to be the clearance that works the best if you're going to have support material in there. So I was able to get them all to move. This one by far had the most support and it had some just build problems. So Amy's didn't come out that great, but she printed one at home that was beautiful. So there you go. I can still pick some of this material out, right? That's in there. That's the support material. It's the same material. It's just laying it up in a very small spread out layer that should break, it should break it up easily. But in the future, if we want this kind of motion and then we want to be able to clean it up, we might need some ports in the side might help to allow us to clean it up, open this up a little bit, open this up a little bit, not of course where the pin is. Where the pin is, it can't be opened, but maybe around it type of thing. So anyway, I think the more we do it, the more we'll get better at it. But I just wanted to show those to you. Good job, everybody. 20 thousandths is what we want in the future. So, all right, that's it. Sorry about missing class today. And we will go after it again. I'll get the chair up because we need to start modeling that, but that probably won't happen today. So, all right.